Hey everyone. In late August, I made a video about trying to use a deep learning model to detect the hand sign for the letter Y in a given image. For those of you who haven't seen it, I'll provide a link to it in the info card. But to recap, I basically experimented with different training parameters, and in the end, I managed to get a network with a test accuracy of 82%. However, I did have significant overfitting with the training accuracy being around 98%. I promised that I'd eventually try to fix this, and now with the ongoing quarantine in the US, I figured that I'd spend some of my free time revisiting this project. So I did that, and I'm happy to say that I got some pretty decent results. Let me show how I did it. So when I first developed the image data collector, I actually forgot to rescale the pixel values, and consequently, some of the inputs could have been as large as 255. Rescaling is not a requirement, but it is very helpful for training. This is because having large initial inputs will result in extreme values for later weighted inputs, and when you pass them through an activation function like sigmoid, the derivative of the cost function approaches 0, which makes it difficult to update the weights and biases. To fix this, I just divided each value by 255 so that the input range was between 0 and 1. Now, as I mentioned before, the main problem I was experiencing was overfitting my network, and the best way to tackle this issue is to just add more training data. However, I had to be careful not to cram too much data onto my memory all at once, so I again scaled down the frame size by half. This made the number of pixels in the image area 4 times smaller, so I could fit 4 times as many images. I also got rid of the exponential decay for the learning rate because rescaling the data should resolve the issue of slow training at the start. Finally, the main script instantiates and trains a neural network using the image data that was collected. So with that done, I went ahead and began collecting all the training and test images through my laptop's camera. Once I had that, I started training a network, and after some time, I got a test accuracy of 87.5, which is already better than what I managed to achieve last time. However, it is a good idea to check the training accuracy to see how much overfitting has taken place. So I made a script that calculates that and ran it on the newly generated network. The training accuracy of this network was about 98%, so clearly, despite the small improvement we made, there is still significant overfitting during training. Now, I also mentioned in my last video that the network will tend to overfit data if it's too complex, and this particular network has 1300 neurons among 3 hidden layers, so there's plenty of room for simplification here. I did some research on what would be a good neural network architecture, and I found this article from Heaton Research that said that a single hidden layer already performs very well for most data analyzing purposes, and that the number of hidden neurons should be around 2/3 the number of input neurons. So I tried constructing a different network that followed these guidelines, but unfortunately this created a huge weight matrix that Python was unable to handle. Because of that, I was forced to reduce the number of hidden neurons to 500, and with that, I got a test accuracy of 82.3, with the training accuracy being around 88%. There's definitely some improvement in closing the gap between the accuracies, but even though we use far less hidden neurons than suggested, there's still a good amount of overfitting present. I started to try out different network architectures and also tweak some of the training hyperparameters. Eventually, I also managed to fit 600 neurons into the hidden layer. I'm honestly not sure how I did it, but I think closing some browser windows might have helped. Anyways, at one point I was struggling to get higher test accuracies, and I didn't know why there was so much difficulty all of a sudden, but I knew that while I was adjusting the hyperparameters, I'd increase the mini batch size, initially hoping that it would improve training. However, after some experimenting, I started to suspect that a larger batch might actually lead to early overfitting. I did some research online, and I found this article on Medium that agreed with my findings. My guess is that a large mini-batch is too good of a representation of the training data, and it becomes easier for the network to find a way to perfectly fit the overall data set. So I reduced the batch size from 100 to 20, and I got much better results. I built one network with 83.1% accuracy and another with 87.7% accuracy. Now, while these numbers are impressive, my goal was to get at least 90% accuracy, and I wasn't able to reach that with any of my networks. But then I had this idea that perhaps each network individually was mediocre, but collectively they might do better if they each contributed towards the final result. This strategy is actually an ensemble technique, which I did mention in part 1. There are multiple ways to carry out Ensemble, but the plan I had was to create an intermediate network that would take the outputs of each subnetwork as inputs, and then produce a final result based on that. Of course, I had to train this network on some data, so I generated another image dataset, fed it through each subnetwork, saved the outputs as part of a new training dataset, then scripted another trainer which, similar to main.py, instantiates the intermediate network and trains it on the new dataset. Now, I should have also prepared a test dataset for network evaluation, but I was just too lazy to do that, so I just evaluated the network on the training set. Usually this is bad practice because the network can overfit and give a false impression of high accuracy, but since I was using such a simple network structure, I was only expecting a small degree of overfitting, so I wasn't too concerned about this. I ran the script for a couple epochs and got a training accuracy of 97.9%. After that, I saved the pickle and got to work wiring all the networks together. I did this by creating a new class called detector, which stores a list of network objects called subnets, as well as a single network object called merger. Next, I created a method called detect, which takes in vectorized pixel data from an image, computes 5 outputs from each subnet, and then feeds those outputs into the merger, which returns the final result. Finally, I created an evaluate method which, as the name suggests, evaluates the performance of the detector as a whole. It does this by feeding the test data through the detect method and compares the results with the correct answer. With the class completed, I just instantiated the detector with the appropriate sub and intermediate networks, and then printed out the evaluation results. After fixing a couple minor typos, I ran the script and got a whopping 93.5% accuracy, which, I'll be honest, I'm pretty happy with. It's not super close to perfect accuracy, but it's high enough for me to work with. Now, if you remember from the first video, the overall goal of this project was to build an application that would open up YouTube whenever it detected the hand symbol for the letter Y through the webcam. At this point, the process to get there is pretty straightforward, but I'm not going to go over it in this video, mainly because I've already packed a lot of information into this part. So what I'll probably do is make another video on the actual development of that application sometime in the future. It should be relatively short, so I expect that I'll get it done pretty soon. Before you go, I just want to let you guys know that I now have a Twitter account. You can follow me at Supreme Sector. I also have a link to it on my channel page. Anyways, that's going to be it for this video. I hope you learned something from this and have a better idea about the various techniques used to reduce overfitting. As always, if you have any questions, feel free to post them in the comment section. If you enjoyed the video, feel free to like, share, and subscribe, and I'll see you next time.